Welcome to Learn Algorithm Design and Analysis course. In this session, we focus on the analysis of naive string matching algorithm. In the previous session, we have discussed the naive string matcher algorithm. Given the pattern P and the text T, we have devised the naive string matcher algorithm to check if the pattern P is available in the text T or not. P is the given pattern and key T and T is the given text of characters. So given the text of characters along with the pattern P, the pattern matching problem is to check if the pattern P is completely available in the text T or not. Assuming that the length of the pattern is M, length of the pattern is M and length of the text T is N, we need to find the number of comparisons performed in the worst case to check if the pattern P is available in the text T. Since in the naive string matcher algorithm, we have started the shift from, that is shift S is equal to 0 to N minus M. Shift S takes a range 0 to N minus M. In each shift, we are performing the character comparisons. The pattern characters are compared with the text characters. Pattern characters P1, P2, etc. Pm. Text characters T1, T2, etc. Tn. The M characters in the pattern are compared with the same M characters in the text array. Initially, we start at shift S is equal to 0. In the first shift S is equal to 0, we have compared the M pattern characters with the M text characters. In case there is a mismatch, right, in the worst case, after checking all characters in the pattern array with the text array, we need to increment the shift, right, next shift S is equal to 1. Then we need to perform the character comparisons, M character comparisons from the pattern array to the text array. Then the last value of shift is N minus M. When shift reaches N minus M, we are going to compare the same pattern characters with the text array characters. So in each shift, M characters are going to be compared corresponding to the M characters in the text array. For example, if the input is pattern P is, for example, AX, text array T is, for example, X. In this case, let's check if the worst case occurs and if you are finding the maximum number of comparisons. So in the shift S is equal to 0, how do we compare AX? 3, 5A, 4, 5A, then X. The character positions are, this is text T, this is the pattern, indices 1, 2, 3, 4, 5, 6. Pattern characters 1, 2. A and A results in a match, then X and A mismatch. So here, two character comparisons are performed. This results in a mismatch. Then shift S is equal to 1. text array A, 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 X. The pattern array is moved one position right direction. So here AX. In this stage, A and A matches A and X. This results in a mismatch. So here two character comparisons are performed in shift S is equal to 1. Then shift S is equal to 2. S is equal to 2. The pattern array is AX, text array 5AX, A, 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 X. Now the pattern is moved one position right direction. So starting from the third A in the text character. Yes, this is A, this is X. This is the text T and this is the pattern character. A and A results in a match, then A and X mismatch. Here two character comparisons are performed. Then shift S is equal to 3, T, 1, 2, 3, 4, 5, then X. Pattern is moved one position right direction. 1, 2, 3, 4th A, X. Here A and A matches, this A and X mismatch. Here we have performed two character comparisons. Then incrementing the shift S is equal to 4. The text array is X. Pattern array is moved one position right, so that here we have the pattern characters AX. In this case, what happens? This A and A matches, X and X matches. So here we have performed two character comparisons. So the total number of shifts are, right, 0 to 4. So 4 minus 0 plus 1, right. So in 5 shifts we have performed two character comparisons. So totally, right, we have performed 10 character comparisons. 2 plus 2, 4. Then 4 plus 2, 6 plus 2, 8. 8 plus 2, 10. 10 character comparisons are performed. 10 character comparisons are performed. So this 10 character comparisons, this is nothing but n minus m plus 1 into m. Since what is n? N is the length of the text. Here what is m? M is 2 and n is 1, 2, 3, 4, 5, 6. N is 6. So substituting here, n is 6. 6 minus 2 plus 1 into m. M is 2. 6 minus 2, 4 plus 1, 5. 5 into 2 is equal to 10 character comparisons are performed. Since the initial shift starts at S is equal to 0, last shift is n minus m. Totally n minus m plus 1 shifts are there. In each shift we are comparing m characters. So m character comparisons are performed. That's what the total number of comparisons. Total number of comparisons performed is n minus m plus 1 into m. So this is in the worst case, this is the worst case number of comparisons. Clearly its computational time is big O of n minus m plus 1 into m. This is the computational time of naive string matcher algorithm. So given the pattern P and the text T, the length of the pattern is m characters, and the length of the text is n characters. The naive string matcher performs n minus m plus 1 into m character comparisons in the worst case. So the worst case complexity is given by a big O of n minus m plus 1 into m.